Welcome back. So now let's talk about some small issues of the particles. If I play the timeline, you can notice that right now everything is looking fine. But there is one small problem. If you notice carefully, none of our particle chunks or none of the debris are actually showing any bounce. If you just notice them carefully, they are just ended up on the floor without any bounce. So that's a very simple way to answer the question that yes, we can go inside the collision sections of the nParticles, and yes, we can definitely increase the value of the bounce. But yes, we are going to do the same thing, but this will give us a problem which is the instability of the particles. Let me show you what exactly I'm talking about. Let's simply select the particles and go inside the collision sections over here, and we have right now the bounce set to the 0. Notice one more important thing. Inside the nucleus, I'm using the use plane, and still there is no bounce inside the plane. Alright, so yes, we are right, there is no bounce because we don't have any bounce, we don't have any magnitude. Alright, so what if I just increase the value of the bounce to maybe let's say 0.85? That's quite a high. So now if I play the timeline, you can see yes, now your particles are simply bouncing. Let me just increase the timeline. So notice, yes, the particles are taking 1, 2, 3 bounce, but there is one issue. If I take you close to the particles, you can see the particle is simply moving very slightly. Let me increase the timeline and take you close towards the other attributes, let's say over here. So notice, there is a kind of very small but yet kind of a rotation inside the particles, and this is just due to the bounce. Alright, but we don't need to worry, we have a provision, we can fix this. Alright, so this can be a bug, but no problem, we have a solutions. So let's do one thing. First of all, before I start fixing this, let's do one thing. Let's go inside the shading sections and change the particle type to the numeric, and let's say we have a speed, because right now it's the speed that is actually controlling. If we just go inside the expressions, you can notice carefully that the spin attribute is just simply an attribute, but it's equivalent to the speed, because the rotation or the orientation or the spinning of the particle is actually getting controlled with respect to the speed. If the speed is 0, obviously there is no rotation. If the speed is high, the particle will spin with a more higher rate. Alright, but the problem is that the speed is not something 0. So because of this 0.032 magnitude, the particles are simply moving slowly, but yet they are rotating, so which is technically not correct. So now let's talk about how we can fix this issue. To fix this, we can go inside the general and we can use an attribute that is called as a bounce scale per particle. Now this bounce scale per particle is actually a multiplier to the value of the bounce. Alright, so if in case I have the value of bounce scale per particle set to the 0, then it simply means that the bounce will automatically become 0. Alright, so let's use some proper expressions to fix this problem. Let's go inside the bounce scale per particle, and let's say first inside the creation, let's assign some random value to this. So let's say we have nParticle shape 1.bounce scale per particle equivalent to a random value. Let's say 1, point, let's say 65. Alright, so during the time of the birth, let's say particle picks the value of 0.65. So this value 0.65 will get multiplied to this bounce, which is over here. Alright, so whatsoever is the result, the particle will take that bounce. So this is for the birth. Alright, now for the runtime expression, let's have a condition. Let's say if we have nParticle shape 1 dot speed, or let's say not the speed, let's talk about the age of the particle. Let's say at certain period of time, at certain age, if the age limit is beyond that, then the bounce scale.pp becomes the 0. So that can be easy to find. So let's do one thing. Let me first of all show you the age of the particles. So that's simple. We can go inside the particle render type. Instead of the speed, let's have the age. So right now, if you notice carefully, well, that's a way too much high because we are at frame 478. If I take you back between a range of 200, and if I play the timeline, let's see the age where the particle have no bounds, and that is something near around the 4, or maybe value between 3.5 to the 4. Let's hide the instancer for a moment for a better clarity. And if you can notice, all the particles are on their way to catch the age of 4. So let's say we have a condition in which in the runtime before dynamics we have nParticle shape1 dot age is beyond, let's say, 3.75. alright, shape1 dot bounce scale pp equals to the 0. Alright, so this way you can have the bounce scale set to the value of 0. So we can have two advantages. First is that when the age is less than to the value of 3.75, then particle can have all the bounces, and the moment the particle reaches the age beyond 3.75, the bounce scale pp becomes the 0, and this 0 will get multiplied to the value of the bounce. So whatsoever is the value of bounce over here, it will become 0 after 3.75. So with that, we can actually stabilize our system. Hit the option edit, and now if I play the timeline, let's say we bring the instancers back, and also let's get rid of this, the age, and use the type as a point again. Let me also decrease the away from the center, because due to the bounce these particles are actually moving way too much away. So we can dip down the value of away from center to, let's say, a value of 15. Alright, now if we play the timeline, you can see the particles are still moving, but notice after frame maybe 140 or maybe 150, the particles are now completely stable. So there is no movement inside this. Alright, so this is a pretty much stable way of handling the particles. Alright, so I hope so guys, you must have understood the concept. Now in the next clip we'll talk about the secondary emission of the particles, so you can say the second level of the debris, and we are going to do this with the help of the emit command. Alright, so see you there in the next clip.